Hi, my name is Sharon. One of the most basic principles of electricity and physics is Coulomb's law. It is the law of force where any two charged particles will create a force on each other. This force between the two objects is known as an electrical force. Coulomb's law states that the electrical force between two charged particles is directly proportional to the product of the charges. So, as you increase the charges, you also increase the force. Coulomb's law also states that the electrical force is inversely proportional to the square of the distance between the two objects. So, as you increase the distance between the two objects, you decrease or you weaken the force. These relationships are clearly seen in a relatively simple equation. Force is equal to Coulomb's constants times the two charges all over distance squared. So, looking at that, it makes sense that the force relating to the charge between the two objects is decreasing as you move them further and further apart.
Hi, I'm Chastity. Electric potential is a pretty broad topic, but simply put, it's the push of electricity through a circuit, and it describes how much force one charge would exert on another charge if they were held in close enough proximity to each other. That was a mouthful, but we're going to use this equation to help us understand. So electric potential is V equals W over Q. That simply means that electric potential, measured in volts, is the amount of work necessary to move a charge across an electric field. It's easy to confuse electric current with electric potential, so it helps to think of electric current as the water, the flow of water, and electric pressure as water pressure. In our faucet example, if we turn off the water, meaning we remove that current, our water pressure would still be held constant. If you turn your shower off, the water stops flowing, meaning no more current, but your water pressure doesn't change. That's important to note because with electric potential, our voltage is held constant across our electric source. Thanks, and I hope that helped a little bit.
Good afternoon. My name is Azaz Chaudhry, and Ohm's law can be summarized into three main components. There's the definition, the equation, and further down in an example. So the definition of Ohm's law is the current through a conductor between 2 points is directly proportional to the potential difference across those same 2 points. So this definition can be visualized as this equation, V equals IR. V is the potential difference across the conductor measured in volts. I is the current flowing through the conductor measured in amps, and R is the resistance of the conductor measured in ohms. So a simple example of Ohm's law is if we look at this 10-volt conductor where the flow of electron goes from the minus end to the positive end. There's also a 2 ohm resistor, so we need to find the current. So using the equation V equals IR, we have 10 volts equals I times 2 ohms. And using simple math, we find that the current is 5 amps. I hope this talk gives you guys a better insight into Ohm's law. Thank you.
Hello, I'm Allison Carraway. We stand upright on the ground on Earth because of a gravitational force and how our body's mass responds to that gravitational force. Well, electric field is how electric charges respond to electric forces. Electric field is an electric force per unit charge, how one charge or many charges influence the surrounding area. The electric force is directed outward from a positive charge, as it is here, and directed in towards a negative charge. The concept of electric field can be applied to charged plates, charged spheres, and charged cylinders, which can all be labeled as Gaussian surfaces. The equation for electric field is E equals F over Q, the electric force in Newton units, and the charge in coulombs. One application of electric field is in the field of tissue engineering. The winter 2008 issue of Organogenesis explained the application of electric fields to organ systems. They found that some organ systems generate their own direct current, the circulatory system in the process of wound healing, and the female reproductive system in the creation of a new embryo. The researchers found that cells do actively respond to electric fields. That was a brief commentary on electric field. Thank you for your attention.
Hello, my name is Noha, and my colleague Azaz has discussed with you the electrical component of current. So here we're going to talk about how the cardiovascular system is physiologically analogous to current. So current is the flow of blood through the bloodstream, and current, as Azaz had mentioned, equals voltage over resistance, and we're going to assume that resistance is constant And here we're going to assume that resistance is constant because it's a normal, healthy body, and the blood flow is being generated by the heart pumping blood from the arteries to the veins. So basically, the flow of blood, which is the current, is going to depend on the pressure difference between the arteries and the veins, and the resistance is constant of blood flowing through the heart. So I hope that helped in understanding how the flow of blood is physiologically analogous to current by being that flow of blood depends on the pressure difference between the arteries and the veins, and resistance is constant. So blood flow equals delta P over resistance. Thank you.